Welcome, curious minds, to another deep dive. Today, we're exploring something really visual. It's about how the European Space Agency's Gaia mission isn't just, mapping stars,
Yeah.
but also completely changing how we see our galaxy through some truly stunning visualizations.
Yeah, and our source material for this deep dive is mainly from an essay by Michael Perryman. It really focuses in on this huge collection of videos and animations, the stuff that brings Gaia's science to life. So our goal today, we want to kind of cut through that massive amount of visual information. We'll highlight the most fascinating, maybe the most mind-bending visual journeys and scientific insights Gaia offers. Basically, give you a shortcut to understanding this mission's, well, its powerful visual legacy.
And it really is powerful. I mean, to really appreciate these visuals, it helps to remember the sheer scale we're talking about with Gaia. It's mapping our Milky Way galaxy in just unprecedented detail, charting positions, motions, properties of literally billions of stars. That generates this, well, enormous amount of really complex data.
And that's exactly why these visuals are so crucial. They're not just, pretty pictures. They actually turn all that abstract data into something you can see, something you can grasp. It makes the cosmos and Gaia's discoveries feel really tangible.
Okay, so the essay mentions that when Gaia Data Release 3, DR3, came out in June 2022, it felt like the visual floodgates just opened. What was it about DR3 specifically? Why that explosion of videos and animations then?
Yeah, DR3 was definitely a pivotal moment. It was incredibly comprehensive, you see. It gave us an even richer data set. And with that came the chance to really show the science, not just talk about it. These visuals, they serve a few critical purposes. Some are there to illustrate the basics, like how Gaia actually makes its measurement.
By how it scans the sky.
Exactly. How it sweeps across the celestial sphere, or how it uses parallax, that tiny shift, to figure out distances. Others are more about describing the data releases themselves, what's in DR3. And then, of course, many directly showcase the really profound scientific findings. And what's quite cool, I think, is that many were made by ESA, sure, but also by dedicated teams within the Gaia coordination units. It speaks to a real collaborative effort.
And you mentioned some key figures behind a lot of this work. Stefan Jordan and Tony Sigrista from Heidelberg, they're known for something called Gaia Sky. What exactly is Gaia Sky? How does it make these visuals so impactful?
Right, Gaia Sky. It's basically it's open source, real-time 3D astronomy visualization software. Think of it like a dynamic, interactive map of the Gaia catalog.
Oh, wow.
Yeah, it lets you literally fly through the simulated galaxy, zoom in on stars, visualize their motions over time. It's not just watching a pre-made video. You can actually explore the data yourself, almost like you're piloting a spaceship.
That sounds amazing.
It really brings the sheer vastness of Gaia's data into a form you can navigate, something almost experiential.
Like a cosmic GPS, as you said. So just how many of these visuals are we talking about? Stefan Jordan, you mentioned, has compiled hundreds. This isn't just a few clips then.
Oh, no, not at all. It's monumental. We're talking about video collections tied to specific data releases. Like DR1 had around 56 videos, DR2 had 27, plus another 15 for scientists. Gaia Sky for DR2 had 73. EDR3, that's the early third release, had about 52, plus 8 more for Gaia Sky EDR3.
Wow. Okay, the numbers are huge.
They really are. And then there are the broader channels and playlists. The main Gaia ESA YouTube channel has nearly 100. General Gaia YouTube videos, maybe 400. The DR3 collection itself is around 100 videos, and the Gaia Sky collection spanning DR1 to DR3 has over 120.
And specific Gaia Sky categories, too.
Yeah, like parallax examples, there are 21 of those. All Sky 360 views, 5 of them. Stefan Jordan's personal channel has nearly 60, and Tony Sigrista's has almost 120. It's a lot.
It really is.
Which raises a pretty important question, doesn't it? How does anyone even begin to explore such a huge, rich collection? It's a bit of a labyrinth.
Yeah, where do you even start?
Well, that's why Tony Sagrista, who was key to developing Gaia Sky, also made, I think it's 9, specific visualization tutorials. So if you're feeling adventurous, want to try making your own cosmic journeys with Gaia Sky, those tutorials are a great place to start.
Perfect. And that leads us right into some of the specific, really useful videos, the source highlights. Maybe we can curate some entry points for people based on the science focus. Let's start with how Gaia actually works. What's one of the most, maybe surprising things these visuals show about the mission itself?
Well, there's some great ones showing Gaia's scanning pattern, how it systematically sweeps the sky. That's fundamental. But for me, seeing Gaia's Lysagus orbit is pretty fascinating. It orbits around this point called L2. a Lagrange point. It's like a stable gravitational parking spot way out past the moon.
Right, L2.
Yeah, and that orbit keeps it incredibly stable, which is absolutely critical for the kind of precision Gaia needs.
Makes sense. And parallax.
Yep. They visualize how Gaia uses parallax, the apparent wobble of a nearby star against the background, as Earth orbits the sun to measure distance. It's a classic technique, but Gaia does it with incredible accuracy. And it gets even cooler and maybe more complex. There are visualizations showing how parallax and a star's proper motion.
That's its actual movement across the sky.
Exactly. How those combine, especially if it's a binary star orbiting its partner, to create this really intricate, almost beautiful pattern. It's the motion of the star's apparent center of light, the photocenter, that Gaia tracks. It tells us so much about hidden companions.
Hidden companions, that's
Yeah.
like cosmic detective work. So cool. Okay, speaking of movement, what about the visuals that take us on journeys through space and even time?
Oh, these are some of the most, well, mind-bending ones, I think. Imagine watching the future of a familiar constellation like Orion unfold over the next 450,000 years, or traveling virtually from our solar system all the way out to the highest star cluster. There's a beautiful one of 1,500 stars in the Pleiades cluster using EDR3 data, and a fly-through of, I think, 300,000 objects from the Gaia catalog of nearby stars.
Just incredible.
Yeah, and you can even take a trip past a few selected exoplanets and double stars from the latest release, DR3 is probably, the closest most of us will ever get to actually traveling between the stars.
I believe it.
Yeah.
Hey, for those intrigued by how stars appear to move from our perspective, these Gaia sky visualizations you mentioned sound amazing for showing parallax and proper motion patterns in different bits of the sky. What makes those views so revealing?
They really make the invisible visible. When you see those distinct patterns, like parallax alone makes stars seem to move in little circles or ellipses annually. Then you add proper motion, their real drift across the sky, and you get these elegant arcs or complex paths. Seeing this visualized in specific regions, like near the ecliptic poles or in Taurus and Gemini, including the Pleiades cluster, it really drives home the three-dimensional structure of our stellar neighborhood. It stops being just abstract numbers on a page. You can even zoom right into the area around Proxima Centauri, our nearest stellar neighbor, and see its motion relative to the background. It gives you real perspective.
That's fantastic. So, moving beyond individual stars or small regions, what about the really big picture? The grand scale of stellar motions that shape our entire galaxy.
Yeah, this is where Gaia's data just becomes completely transformative. We mentioned seeing, was it 96 million stars moving over 80,000 years, including effects of their brightness and color changing?
Incredible visualization.
It is, but there's more. Visuals showing the full 3D extent of the Hyades cluster, revealing its tidal tails. These are streams of stars being stretched out and pulled away by the Milky Way's gravity. It tells us how clusters form and eventually dissolve.
Wow, so you can see the galaxy's gravity at work.
Exactly. And there are visualizations showing that our Milky Way isn't perfectly symmetrical. It's actually kind of warped and asymmetric in its motion. That challenges older, simpler models.
Yeah.
And for the real deep dive, you can see how astronomers use the motions of distant quasars.
Those are supermassive black holes at the centers of other galaxies, right? Very distant.
That's them. Extremely distant and therefore almost stationary on the sky. Gaia is so precise it can measure a tiny apparent shift in their positions caused by the solar system's own acceleration as it orbits the galactic center. It's called aberration. Mind-blowing precision.
That is mind-blowing, just incredible. So Gaia can reveal these really subtle, fundamental dynamics. Does it also zoom in on specific types of stars or maybe unusual cosmic events?
Oh, absolutely. There's a whole range. You can watch the distribution and movement of 230,000 white dwarfs. Those are the dense remnants of stars like our sun after they die. Seeing them move over 500,000 years is like watching the stellar graveyard evolve.
A stellar graveyard, wow.
Yeah. And there's a fascinating collection showing the orbits of binary stars. Hundreds of systems, relatively nearby within about 160 light years. Seeing those intricate dances is amazing, and perhaps most dramatically, there are videos about the discovery of and even a simulated voyage to the black holes Gaia found, BH1 and BH2.
How did it find them if they're black holes?
Right. It didn't see the black hole itself, but it saw the tiny wobble of the companion star orbiting the unseen massive object. Pure gravitational detective work based on precise motion measurements.
Incredible.
And there's another really unique type of visualization, a map showing microlensing events. That's when some massive object, maybe a star or even a planet or black hole, passes in front of a distant background star. is gravity acts like a lens, briefly magnifying the background star's light. Gaia's photometry, its brightness measurements over time, pick these up in DR3.
So it's seeing invisible things by their gravity.
Pretty much. And these are shown in really compressed sequences, like 30 or 90 seconds, some even set to music. It's a very different way to visualize hidden mass in the galaxy.
That is amazing. Finding black holes, seeing invisible objects, just incredible work. Does Gaia also bring the focus closer to home, though? Like our own solar system?
It does, yes.
Yeah.
It's not just about distant stars. There's a great tour through the asteroids included in Gaia DR2, and even better, with DR3, you can see the orbits of over 150,000 asteroids. Gaia sorts them out. Two main belt asteroids between Mars and Jupiter, the Mars crossers, the Jupiter Trojans that share Jupiter's orbit, also near-Earth objects, and even the brightest objects out beyond Neptune, the trans-Neptunian objects.
So it's mapping our local neighborhood in detail, too.
Unprecedented detail, really. It gives us this incredibly precise picture of all these, well, leftover bits from the solar system's formation.
Fantastic. Okay, so finally, pulling it all together. How do these visuals help us grasp the broader scientific story Gaia is telling about our galaxy as a whole?
They really create a holistic view, I think. There's, for instance, a captivating journey that unravels the chemistry of the Milky Way. It shows how different elements are distributed, which tells us about the history of star formation and galactic evolution.
Seeing the chemical fingerprint of the galaxy.
Exactly. And there's a crucial map of galactic extinction from DR3 that shows where dust and gas block starlight. You need to account for that to understand star brightness and distance properly. And then there are just numerous maps constructed from DR3 data, showing stellar ages, metallicity.
Metallicity being the heavier element.
Yeah, the amount of elements heavier than hydrogen and helium. Also maps of 3D velocities, how densely stars are packed in different areas, radial velocities. Even maps showing the distribution of those distant quasars and other galaxies that Gaia observes. It's building this incredibly rich, multi-layered picture.
It sounds incredibly comprehensive.
It is. And for astronomers studying stars themselves, there's the golden sample of certain types of stars, FGKM stars, plotted on the Hertzsprung-Russell diagram. That's that fundamental plot of stellar luminosity versus temperature. Seeing Gaia's precise data populate that diagram is really satisfying. Oh, and there's even a visualization showing how they build a composite quasar spectrum by combining tons of individual Gaia observations.
What an absolutely incredible, expansive view of the visual universe Gaia has opened up. It really does seem to transform this complex, almost abstract data into something, well, understandable and often just beautiful.
It really does. I think these visuals are more than just outreach. They're powerful tools. They genuinely allow us, and scientists too, to see the universe in motion, to really comprehend its fundamental processes. They translate what could be just rows and rows of numbers into tangible cosmic stories. It kind of empowers a cosmic literacy, doesn't it?
Yeah, it really does. Which makes you wonder. Here's a thought to leave you with. How might these innovative visual storytelling techniques pioneered by missions like Gaia fundamentally change how other scientific fields communicate their complex discoveries in the future? Could this kind of approach help democratize understanding across all branches of knowledge? Something to think about. And if you are itching to explore these visuals right now, you absolutely should. You can find tons of them by subscribing to the Gaia Sky and ESA Gaia YouTube channels. Just search for @GaiaSkiDev, at StephenJordan3942, and at ESA Gaia Mission 2542. Definitely go check them out. Go explore the cosmos.